Hello everyone, and welcome to astronomy class. Today's going to be a short class. I just have a couple things I want to talk about, teach you guys about. Would love to get through the stars, our sun, and black holes. I doubt I'll even get through the first one. But just some little facts and some things. But before we get started, before I go into any class that I teach, but especially my astronomy classes, two questions for all my students. Number one, did you get 5 or more hours of sleep last night? I should ask if it's 6 or more, but I know how people are, so I ask 5 or more, because at the very least you need to be getting a good amount of like 4.5 hours or more of sleep. That's like the minimum. So did you get sleep? You know, I can't have you raise hands, so I have to adjust this part of my class, but hopefully you got rest, because in order to learn, you need to be well rested. The other thing is, did you eat before class today? I don't know what time it is where you're at. Maybe it's very early in the morning. Maybe you're just eating breakfast. Maybe it's dinner time. Maybe it's midday. Maybe you're at work. Maybe you're on lunch. Doesn't matter. Did you eat? Because learning and thinking takes calories. And you can't learn and think if you don't have fuel for your body to learn and think with. With those two things out of the way, let's get started. Let's learn some astronomy. The first thing I will do is I will ask you little exercises here for you. What do you think of when you think of astronomy? You can take a minute, just pause the video, take your time, write what you think you know about astronomy, write what things you think about when you think about astronomy. I'll give you a few seconds. All right. So, lots of different answers here. Lots of different things are totally valid answers. What I think of when I think of astronomy is I think of space, right? Like I think of the stars, I think of rocket ships, I think of stars, I think of the sun, I think of black holes. Something else that I think about is history and culture, and how astronomy has shaped a lot of history and culture, and how it's very, very intertwined with a lot of history and culture. There are many experiments, many different things that are historical events that we take for granted that wouldn't have happened if it weren't for people in our past and in our present currently looking towards the stars. Lots of things to think about and learn about when we talk about astronomy. So first things first, we'll talk about stars. What is a star? We'll do the same exercise. You can pause the video here. What do you think a star is? What do you think about when you think of a star? Maybe you think of specifically our sun, but define what you think a star is. This is a very engaged activity. All of these are meant to get you writing and get you thinking, and give yourself an understanding of what you think these things are. Give it a second. You've probably paused and unpaused the video by now. So, stars are giant balls of gas. And that's a bit of an oversimplification, and we will be getting far more in depth. This is just our first beginner session here. This is just to get us thinking about astronomy, get us thinking about how we should be learning about astronomical topics and how they connect to other things in our world. Stars are really, really cool. They make up the entirety of our universe. They are mainly composed of 2 elements, hydrogen and helium. However, depending on the age of the star, the composition might also change. It is very possible for heavier elements to be present in a star, and in fact, fusion, which again, much more advanced topic, which we will talk about in a more advanced class. Excuse me, I apologize. See, this is what happens when you eat right before classes. Sometimes you burp a little bit. That's okay. But stars have fusion, which again is something we'll talk about later. But basically, fusion, for our basic level of understanding here, is when 2 elements, 2 atoms of an element, let's say it's hydrogen and hydrogen, they combine together and they fuse and they make a heavier element. In the case of hydrogen, hydrogen and hydrogen would combine and potentially make helium, and then we can go from there. It's a lot more complicated than that, but for now, base level, that's where we're going to start. It's okay. That's great. So now we have a basic understanding. Stars are giant balls of gas, mainly composed of hydrogen and helium. They're really bright though, and they're really hot. And there are a lot of different types of stars. You might have heard something called a neutron star before. There might be a Kurzgesagt video recommended in this feed on the side over here. It's totally possible. All of these things. Minute Physics also has some really good stuff about stars from what I remember, and there's plenty of crash course videos about different astronomy topics as well. But I'm going to teach it my way, and I'm going to teach it comprehensively, and we're going to keep talking about it, and we're going to keep learning. Ignore that noise, please. I apologize. So we have our understanding of stars. We have a basic thought of what they are, what they're made of. Why do we care? Why do we care about what stars are? Well, for starters, our sun. Our sun is a very important star. In fact, it is the most important star in all of our lives. We, on the planet Earth, live in something called the Goldilocks or the habitable zone in our solar system. Now, quick little fun fact, and I will put my mic down so I can write this on the board. Sorry for the mic noises. This is what happens when I hold it. Fun little fact. Solar system is what we call where we live, but Sol in particular, S-O-L, is the name of our sun. Our sun has a name. We call it the sun, but it's Sol. It is the core of our solar system in literal words, and the core of our solar system in physics as well. You might know that the planets orbit around the sun. You can take a note here real quick to test yourself and see if you can name all of the planets and see if you have a way of remembering them. Just a fun little exercise to keep your brain thinking about these things and keep writing about these things. It's very important while we're talking about these that we make stories and make connections. So Sol, S-O-L, this is the soul of our solar system. It's the core of our solar system. The sun sits at the center and the soul of our solar system. So that's some fun things to just keep your brain thinking, keep reminding yourself about what the shape of the universe is and understand the composition of it and what things are made of. Our sun is one of many stars. We can look out, and this actually is a constellation. We'll let you guess what the constellation is based on the shape. Maybe you don't know the name of the constellation, and that is okay. I literally just drew dots on a whiteboard. It's okay if you can't figure out what the constellation is. But I drew a little shape here to show constellations, because constellations are great ways for us to remember what things are in the night sky, and specifically to tell stories about where the positions of stars are and how to track the movements of those stars, because our brains love patterns. Our brains love patterns and they love shapes. So when we can look at the night sky and we can see stars in different shapes, we make shapes all the time. We look at clouds and we see puppy dogs, and we see someone dunking a basketball. We see so many different things. And stars are the same way. Our brains look at them and we go, ooh, we can make shapes out of those. Our brains love making shapes. It's why when we look at different things, I bet you could like see a face in this if you really tried. Like this could be the mouth with a mustache, and like maybe the eyes are like up here. Maybe these are just like a unibrow. Maybe there's like two dots right here that you can specifically see. You know what I mean? Like, we're getting on a tangent. This will happen a lot. Don't worry. That's okay. We're learning. We're experiencing things. But our brains love patterns. So when we talk about stars, we want to talk about constellations. We want to talk about something like the Big Dipper. We want to talk about Ursa Major, which is the constellation that the asterism of the Big Dipper lives in. So a constellation is a actual like term for what we use to call different shapes of stars and patterns of stars in the night sky. And an asterism is kind of like it's a colloquialism. It's a shortening. It's a subset of stars that is more popular, or a slightly different group of stars that is more popular. So we can talk about Ursa Major and Ursa Minor, the Big and Little Dippers, and things of that nature. So fun little facts there to keep us thinking about constellations, to keep us thinking about different stars. Unfortunately, I don't have access to a planetarium to show you guys a really cool, my goodness, to show you guys a really cool look of the stars in the night sky. I really love to give those presentations because you can name stars in the Big and Little Dipper, and then you can go to like the winter hexagon or the summer triangle, and then you can start listing all of the different constellations in those two things. So the winter hexagon is Canis Major, Canis Minor, Orion the Hunter, Taurus the Bull, Gemini the Twins, and Boötes the Herdsman. I remembered them all. And there's multiple different stars that make up one from each of those constellations that make the winter hexagon. So that being said, we're going to refocus back towards what we were talking about, stars and our sun and our solar system. We probably won't get to black holes, but they're very connected to stars and our sun, and we will talk about that. These will be other things that we talk about, but for right now, this is what we're going to focus on. So why do we care about what stars are made of or what shapes they make? I will let you answer that question on your own. Why do we care? Why do we care what stars are made of? Maybe you have your own thoughts about what the priority of this could be. Maybe you have a basic understanding of like, oh, I'm curious. Maybe it's just curiosity, right? There are plenty of different valid reasons for us to research things and for us to understand different things. And something that has happened a lot lately, which I will bring up pretty consistently in my other videos and in these astronomy class videos, is that fascism and capitalism are very explicitly meant to eliminate the value of education for learning's sake. I'm going to say that again. Fascism and capitalism specifically aim to eliminate the value of education for learning's sake. They do not value learning for the sake of learning. They do not value learning to gain knowledge. If it does not have a value that can be extracted from it, it does not matter to capitalism, does not matter to fascism. We will talk more about that in later classes when it becomes far more relevant for very specific topics. But for right now, we're going to keep it more basic. We're going to keep it, and we're going to talk about why we do research. So the first thing is, space is really cool. Space is really, really freaking cool. It is the number one thing that I tell everyone that asks me why I study astronomy. It's really cool. Space is cool, guys. I don't know what to tell you. Space is really, 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 really cool. So when we study astronomy, we do it, one, because we're fascinated. That's what piques our interest, right? You might have clicked on this video because you're like, oh, an astronomy class. Let's see how it goes. Let's see if we can learn something from this. Let's see if I can learn something from this. Let's see, maybe I feel the urge to learn something about astronomy. That's awesome. That's getting your foot in the door. That is a good practice to have, is learning something because you are curious. Another reason that we might study stars or astronomy in general, there's a lot of value in astronomy, not just in the science of it and the incredible historical progress that we have made in pursuit of astronomy. The things that we have accomplished through the study of astronomy are incredible feats of engineering and science and humanity. We have gone to space. We have taken pictures of black holes. We've done incredible, awe-inspiring things with astronomy. But none of these are necessarily, how do I say this? None of these are necessarily direct ways that we could be very engaged and say, yes, this is why we study astronomy, to solve this problem, right? There's not an inherent problem that astronomy seeks to solve at first glance. In reality, it has already solved so many problems. Number 1, a calendar system. Number 2, navigation. Number 3, we now have GPS based off of that navigation. Number 4, we understand tides because of this, and therefore we can go out to sea and be safe and do all of these different things. We have such great understanding because of our slow, methodical progress with astronomy. It is one of, if not the, oldest science. Try not to make mouth noises into the mic. I apologize if I am. So now we're going to refocus and we're going to come back and say, okay, what about stars specifically? We've talked generally about astronomy and we can see some value in there for sure. And there's stories to be told with all these things too. And it's very important that we carry that history with us so that we understand where this knowledge came from. But why stars? Why stars in particular? We see them all the time. We see the sun all the time. We see stars at night all the time. Why do we want to study them? They're all so far away. Why does it matter? And the answer there's many different answers. I'll give you a second to think of one or two. Maybe you have 3. But why do we study stars in particular? Because we can learn so much from them. We can learn so much about the composition of stars and therefore what they are made of and how they are made. And that means we can figure out how our sun was made and how the solar system was made and the origins of life as we know it. Are you kidding me? That's a good reason. That's a good reason to study stars. We can figure out what they're made of. We can figure out how they were made. Another really great reason, which is something that I use as my reason why I am interested in stars, they do this thing called fusion, which I alluded to earlier. I mentioned it. It's when 2 elements combine. Fusion releases energy. It'd be great if I could actually speak full words. Fusion releases energy. There is a big desire and a big need for energy on this planet. If we could figure out how to replicate fusion energy on our surface, on Earth's surface, we could have infinite clean energy all the time, everywhere, for everyone. That is really cool. And there's a lot of really amazing scientists doing around the clock work on this. And I say around the clock because it's happening around the world. There are multiple different institutions. There's always research. There's always a startup of some kind specifically researching fusion, specifically cold fusion. But that's, again, much trickier topic. And there is a YouTuber that I can't think of off the top of my head, and I feel so bad, but he's really awesome. He's got long hair, beard. He talks about nuclear energy all the time. He's a great proponent for nuclear energy. I will link him right here. So he'll be one of the many links that I put in this video. But that being said, how long? Oh my gosh, this is already a 20-minute class. Okay, we're gonna try and keep classes under about 20 to 25 minutes. So I'll ask one more question at the end of this class here today. First of all, I hope you learned something a little bit. Very basic class. We'll get more into details of how stars are formed, what it means for stars to form. We'll get into like a layer 2 and a layer 3. I have taught every single age group of science. I've taught elementary, I've taught middle school, I've taught high school, and I've taught undergraduate. So I can do all the levels. So we're starting very simple. We're starting with like a middle to a high school range education here, just to give a baseline. We're just giving a baseline. Don't worry if this was too complicated or not complicated enough. There will be more classes. I promise you that. And the last question before we end the video here for today, the last question is, what would you like to know about stars? And what did you learn about stars today? So just go ahead and write those. Maybe write them in the comments. Would love to see some questions in the comments down below while you're there. Maybe drop us a like and subscribe. And we'll continue these astronomy classes next time. I have been Eris. I just realized I didn't introduce myself at the beginning of this. I might record a separate intro just so we can make sure we do that. But I've been your professor, Motorcycle Eris Dawn, and welcome to astronomy class, everyone. Thank you for coming. Bye now. Bye-bye. I've got nothing else. I'm just going to keep waving. That's all I had for this video. That's all I had. 21 minutes. I talked for 21 minutes about this. It's fine. I'm good. This is good. This is good.